Good morning, everyone. Welcome to the Terraform 101, How to Make Snowflake Objects with Code Lab. I'm Phoebe He, product marketer here at Snowflake. Please make sure you have your quick start get ready. You can find the link from the resource tab. And also, the recording will be sent out after 24 hours. And please send us any questions if you have along the way. So with that, I'll pass to Brad for the real thing. Brad, take it away.
Thanks, Phoebe. Today, I'm going to go through Terraform 101. First thing I want to do to just set the agenda for the day. So first, I'm going to go through what is Terraform for those here that aren't familiar with the technology. I'm going to walk through the quick start that's available. That involves a setup of Terraform as well as installation. We then create objects in Terraform. We update and change some objects using Terraform as code as infrastructure. And then at the very end, I go through some best practices for you to be successful using Terraform with Snowflake. For those here that aren't familiar with Terraform, Terraform is a technology that was developed by a company called HashiCorp. They built this to be able to provide infrastructure as code. And there's a trend in the industry to move to infrastructure as code because a lot of operations teams want production environments which are easily reproducible. So imagine an organization that needs to deploy many different cloud deployments in different regions, as well as like people using systems that need to be heavily audited. So people and teams that want to be able to make sure that anything that happens in production has an audit trail for who did it, when they did it, and that can easily be both tested as well as verified before landing in production. So there's a trend in the industry to this infrastructure as code. Terraform is a tool that allows you to do this. And it not only supports Snowflake, they also support Amazon, Azure, and Google Cloud. So it's a tool that actually has many different providers for different backends. And that one tool allows you to manage infrastructure in any of those systems, as well as many others, whenever you want to manage your infrastructure as code. Terraform is open source. They also have a cloud version, which is a paid service. Most customers I work with are running the open source version, but the cloud service also has some advantages, mostly around using them for shared persistence. And I'll talk about that a little bit towards the end in best practices. The hands-on lab, also, if you need to look at this later, it is in the resources tab. You can also go to this tiny URL and you can open it up. And so I'm going to jump over to the hands-on lab now. This is what you should see inside the hands-on lab. We do a quick intro of what Terraform is again. But what you'll need is down here at the bottom. And I've already got several of these things set up inside my environment today. So I already have a GitHub account already set up. It's already configured inside of my console. I already have installed Git. I'm going to use VS Code today. So my text editor is already installed. And I use Brew to install Terraform prior to this quick start. So if you're that far along, we can go ahead and continue and jump right into creating this new code base, which is going to manage Snowflake objects. If you're unfamiliar with Git, we have also produced all of the commands necessary to actually create a repository on your local system. This is a good simulation to show what it would look like in production if you wanted to have a repository managing all of your Snowflake objects, basically from the beginning through any changes you have in the process. Today, I'm going to skip a lot of these Git commands because it's not directly related to Terraform and more of how you incorporate Terraform inside your continuous integration environments. But they are available in the quick start for you to follow along if you desire. These are all optional if you also want to skip them. The first thing you'll have to do is create a service user. To create a service user, you'll go out to a terminal and you will run a few commands. These commands will eventually create a public and a private key. I've already created these public keys and the private keys inside of my console. So I've already ran both these commands. And now I'll show you how I created this user inside of Snowflake to authorize this new Terraform user access directly to Snowflake. And what this is going to do is whenever I run Terraform, it's going to be running as this user. So I'm creating this user basically as a service account. This is going to need to have decent authorization because we're actually managing infrastructure here. So this is going to be ran as the account admin role to give them the access they need. If you look at what I ran earlier, I created this user. We labeled it tf-snow. And I set the public key from the response of what that command did earlier. So now I can do key pair authentication with this user and send in any of the Terraform, any of the things that need to be ran inside Terraform can be executed in Snowflake as this user account with these credentials. So let me go ahead and show you. Basically, I had already added them to the sysadmin role. So they are a sysadmin, and they're also a security admin. So this is going to give them quite a bit of access. I ran this as account admin, as I mentioned earlier. But now this tf-snow user can be used inside of either my command line, which I'll be doing here in a minute in Terraform, but also could be executed as part of your continuous integration environments. So I'll show you this user is created. So you see here, we have a username named tf-snow. If I scroll down, you will see that it has this public key. So that means we're going to be able to do public key off, and that's the same public key I showed above. We want to see what grants I've given to this user. You'll see I've given them both security admin and sysadmin. So it's a fairly highly privileged account to be able to do all the Terraform operations. So now we're already past this section here. We've got the service user created. We're going to use this service user inside of Terraform. To set up this local environment, we need several environment variables. To do so, I need to get some information from Snowflake. What's really important is this account locator, as well as the region that I'm deployed in. You may know this already if you're familiar with your Snowflake account, but the SQL command also gives this to you if you need it. So here you can see this is my account locator. I'm going to run the demo under today, as well as this is the region identifier that I can use. I'm going to plug both those into the environment file, and then I'll be able to actually run Terraform as these credentials. So Terraform automatically looks for all of these environment variables and will authenticate the user recording. Let me show you that. So I'm going to jump over to VS Code. And here you can see I already have this environment set up. You can see my user is tf-snow for the name. We have a private key path. This is the account name for the one that I just got from Snowflake. And my Snowflake region is US2 West. You can find also some documentation on Snowflake on how to set these environment variables. After these environment variables are already in the environment, so if I do, go ahead and load those. Okay, we can see they're all loaded now. So Terraform can now basically operate as this user credential. To start with Terraform, what most customers and what most people do in Terraform itself is they have like a main.tf file. You can organize your projects in many different ways. But the simplest project, you're going to see something like a main.tf. You may see some inputs as well as outputs inside of TF. You'll see I've done this in the example. But it just depends on how large your projects are and what your naming conventions can be. But you can have a whole folder full of many files, and they can be namespaced however you need them to be. With this being such a small example, you're going to see everything I do today inside the main.tf file. But do know you could create any number of .tf files inside this folder structure, and they would be runnable by Terraform. So in the website, on the quick start, you'll see we're pulling in version 0.35. This morning, I updated that to 0.59 just because I want to be running on a more recent version. And while you're running this locally, also feel free to change this to whatever version you want to run on. So what this is doing, it's pulling in the Snowflake Labs version of our provider, a fairly recent version of that. And you can see here, I'm running this provider as sysadmin role. So that's going to give me quite a bit of access to be able to operate on this account. And I want to be able to create several resources. The resources I'm going to create are at the account level. So if you look at the next section here, what we're doing is we're creating the database as well as the warehouse. Inside my local file right now, I have more than this specified. So I'm going to run a special Terraform command that only creates these two objects. But imagine my main.tf just has these two objects in it. And I'm going to have Snowflake create these two for me. So right now, my Snowflake account, if I do anything like describe database, does not exist. Where else does not exist? So right now I don't have either of those things existing, but I'd like Terraform to create them. So let's go out and have Terraform do that. So here we go. I'm going to run Terraform. I'm going to apply. And then I'm going to specifically target those two resources for now. And if you do what's in the tutorial and you do just have a file that only has a few objects in it, you won't have to do this target, but I'm going to do it to start with. So I'm going to have it create the database. When you tell it to create the database, you'll see it actually asks you to verify what's happening here. So you can see it wants to create a database. It's going to add one, no other changes, and destroy nothing else. So that looks good to me. I'm going to go ahead and say yes. So now that resource has been added. Let me go ahead and add the warehouse also. Again, it's going to add one item. It shows it's going to create a warehouse, it looks like. Yeah, warehouse will be created of size large. That looks good to me. That's automatically created. You can also run a Terraform plan if you want to look at that preview, but I usually just do the apply when I'm working locally, and then I can see exactly what it's going to do, and then say no if it looks like it's going to do something that I wasn't expecting. In this case, I expected the database and the warehouse to be created, and those were created. Let's just go here and look at Snowflake and see what this looks like. Hey, we have a database now. That's pretty awesome. And we have a large warehouse we can use. So it created both those objects for me. That's pretty nice. If you look here, it's been set at 60. This was a large. We go out and look at this inside of this large. Auto suspend set at 60. So it set up everything properly the way I wanted to. You can see it also had the other defaults. So if I did want to modify and use other cluster counts or anything, I could have put those into Terraform also to manage those objects. So we've landed those out into Snowflake, and that's pretty cool. That could have been committed then into GitHub, and you could have continuous integration system also do that in another environment if you wanted to. Often that's done, after this has already been manually tested. So in this case, I had already set up my local environment. If you were going to do this inside of a clean environment, you would have to do a Terraform init before you do the apply, or you'll get an error telling you need to run the init, but it guides you through this. And I talk a little bit in here about how, if you are going to commit these into Git, how to manage state. But I'm also going to talk at the very end about some best practices around state. And mostly I would be doing this type of process like I'm doing right now when I'm developing a new module and developing brand new Terraform code, not after I actually have it ready to be produced or submitted into source control, ran in a CI/CD system, and then automated. A lot of customers want to be able to control all their infrastructure through Terraform. So running things locally as account admin, like that's okay pointing to like a dev environment. But at some point that usually gets locked down in tests, like in a staging or another pre-production environment. And then those environments are audited and checked before it lands in production. This also walks through like what you'd be doing in Git here. So I could also take this main file I have now, commit that into Git, and then you could run something like a GitHub action. Or you may like Jenkins or Circle CI or another tool. You could use any of those to then take that main.pf file I just authored and run that inside of a staging, pre-prod, or production environment automatically. So this talks through a little bit of what I did here. I did put the filter in place right now because I did want to not have it create everything quite yet. In this next block inside the quick start, you'll see we start adding a lot more things that we need for this specific use case. So in this case, I'm creating a new role. So we have a service role where there's going to be like another credential created that's talking to Snowflake with another right, like as a user right into this database. So I give it a database grant so it can use this database I just created. And then I will create a user that's going to be along as part of that role. I create a schema to be able to namespace some new data that's going to be coming in, grant access to that schema to the role, grant the warehouse usage to the role, and then I create the user, as I said, and then link this user to the role. So now I'll have a brand new Snowflake user named tfdemo user that has a key pair that has access to the warehouse I just created. This will have access to the role, which has access to the schema, as well as usage access on the database. I think that's all it's going to do. So I'm going to go ahead and run all of this, and then you'll see all these things automatically happen, which is pretty nice. So this time I will just do a Terraform. What's really nice here is it knows it already created that database and warehouse. So you're going to see it's not going to change those at all. So it's going to add 9 more resources. That's all of the things I just talked about. It's going to add those users and the warehouses and schemas and the grants, everything. I'm going to let Terraform do this. And it's done. And now I've got a public key I can use to then authorize that user I had also created. So let's go out and just take a look at the environment and just verify that all of those things just happened successfully. Not that I don't trust or Terraform this. So if we look at this, I'm going to go ahead and describe that other user. Let's see here. I'm going to describe this user. You can see the demo user does exist. That's pretty nice. It does have a key pair that we can use. And you can see it has that service role. So it was able to run this. So we've shown adding a lot of new resources, but I didn't really show like how could you change this in production if you needed to. So I'm just going to do a few examples of this. Let's say maybe we were doing some testing and maybe we decided we were too aggressively suspending these warehouses. So maybe we want a 2-minute suspension time. And maybe we also decided that actually large was larger than what we needed. So actually we'd rather be running a medium warehouse here. And we're going to let it go to 2 minutes before it suspends. I've also found out from the team that's using this role that they need more than just usage access. They need to be able to maybe operate the warehouse. So in this case, let's go down and look at this warehouse grant. And let's make sure they have access to operate. So operate and Snowflake will allow them to do things like change the size that they need to themselves, suspend manually if they needed to. Imagine something like an on-call that needs to be able to go out and manage this for some reason. So I'm going to add that new grant. So in this case, we're going to give them the ability to operate this new warehouse, as well as I've changed the size of the warehouse. I've changed the time out of the warehouse. Maybe let's also give that same person access to monitor the database. So let's look for the database grant. And we'll give them monitor here. And monitor allows them to look at like basically, what's happening inside the database itself. You have to watch out for that YAML. Sometimes that will get you killed. But here we go. I'm going to do another Terraform apply. And this is going to create a few more grants, as well as change. See, it's going to actually modify that warehouse. Let's go up and look at that. It says I'm going to change something. So here, you actually look at that warehouse. It says, hey, I'm about ready to change the auto suspend from 60 to 120, warehouse size from large to medium. So this is a great point in time to like go out and make sure, like, hey, a lot of people say Terraform's magic and it's not, it's doing things I didn't expect, but it'll tell you exactly what it's going to do. So, usually that's people that aren't looking at these change sets and really noticing the fact that, hey, it says it's going to change the suspend and warehouse. This wasn't expected. Then go back and check of like, why is Terraform trying to do this inside the environment? So in this case, this is exactly what I wanted to do. I wanted to resize this. Let's go ahead and let it run. And again, this could have been ran inside a CI/CD system, inside of a continuous integration system after I committed into GitHub, if that was desired. But this already changed those two, added the 2 new grants, as well as changed that warehouse. So let me just show you what that warehouse looks like now. It's a medium now. Timeout's 120 seconds. So you can see how easy that is to actually do that. So hopefully you can do this also on your own when you're going through this quick start. If you wanted to play around and change, you could change the bit strength of the RSA key, or you could play around with like giving them more or less access into this role. And then you could, again, follow the Git flows and then apply more changes. And you can just iterate on it. So test creating more databases, test changing some of the parameters inside of there, and just keep on running Terraform apply. What's really cool is if you run it and nothing's actually changed. Because hey, we don't have any work to do. So actually, it's really efficient to do those comparisons between. This is what I want that converged environment to look like. This is what I said I wanted the destination to look like. If it already looks the way I wanted it to, and I didn't really make any substantial changes or any changes, then it'll automatically do no work, which is really nice. Other thing I love about Snowflake is how easy it is to clean up when like doing development or testing. So I'm going to quickly clean up after myself and then show you how that ends up. But one command is going to destroy everything. It understands all the dependencies of all of the different objects and can automatically tear down everything it's created. So everything's destroyed now. So I'm back down to a completely clean environment with no Snowflake objects at all. So let's go out and just take a look around and just make sure Terraform did exactly what I wanted to do. The database is no longer there. Let's look for the warehouse. The warehouse is no longer there. Let's look for the user. The user is no longer there. So it did a great job of cleaning up after itself. But let's say I want to go and do some testing again. Look how quickly it is to bring up that environment. So the Terraform is really great for bringing up these environments to say, I need a development environment to be able to run a set of tests, or, I want something in like a development environment for a teammate to be able to do work. And if these are in Terraform, look how quickly that was to be able to create up a known state, a known environment inside of Snowflake that's set up exactly the way I wanted it to be, without clicking in the user interface and clicking around trying to get it set up right. It's conformed to exactly the way I want it to be within seconds. And then I want to make sure there's no, all right, make sure there's no, nothing left over, no wasted services running. I can just go ahead and have it destroyed automatically. And you could also do this. We have a lot of customers that do this with, they'll have their CI/CD systems where they bring up ephemeral environments for development teams, and they just destroy them frequently because they're like, hey, these are testing environments, these are pre-production environments, and running them 24 hours a day can get expensive and also is unnecessary. So they'll have a lot of these actually auto tear down these ephemeral environments and bring them up as needed during their workflows of like, how do they develop new features on top of Snowflake? That was super quick run through Terraform. I want to get through and go back to a few best practices. So that's got us all the way to the end. Hopefully you get time to get through there also. We may have gone a little too fast for you. So feel free to go back and do anything again if you need to. But I want to talk about some best practices in Snowflake just to make sure that we're setting you off in a good direction. And these are things I think will end up saving you time if you think through them and just make sure that you're using Terraform in a way that's going to work well. The first thing I like to make sure that everybody does is create the objects you want to manage from code in Terraform. Creating the objects in SQL inside the console and then importing to Terraform is kind of defeating the purpose of code as infrastructure. You're manually creating an environment and then trying to import it into another tool. And I'd say there's not really any guarantee at that point that infrastructure was really created that. Because now you've imported something you've manually created with SQL. And as you saw how quickly it was for me to work in Terraform there, creating some YAMLs would be faster than clicking around a UI or building SQL and creating a lot of these objects. So I like when customers think of this, like, you think about like test-driven development. I think like creating objects from the beginning in Terraform is the best way of doing this. I understand it's not always possible, but it looks a lot better, especially around if you're creating new objects, not starting with SQL inside a console and then trying to reverse engineer what the YAML will be. A lot of people say like Terraform is slow and it's complicated. I'm like, well, show me your workflow. And they're often creating everything in SQL in the console and then reverse engineering what they just did in Terraform. When the object could have been created in YAML in Terraform from the beginning, and that would be in a known state and done once with no SQL work at all. Dependencies is important to think about whenever you're putting things in Terraform. It gets really complicated if you have some things managed in Terraform and some things managed outside of Terraform. Imagine the case I just showed, like a warehouse that's created inside of Terraform, but then some teammate that's managing roles with access to that warehouse or database from another tool. Like maybe they're running SQL. The reason that's complicated is, well, if a teammate ever goes out there and does change that role or reapplies Terraform or creates another environment, that other tool has no idea whether that's created yet or not, when it should run or anything. So with Terraform understanding its own dependencies and the execution order of those, it's really nice to manage anything that is dependent inside of Terraform itself. So in the case I showed earlier, I think it would have been really messy to start managing like those, especially those roles and access to those roles in some other system, not using Terraform. State is something I would talk about. I think this is one of the biggest pros of using Terraform Cloud is they have a state provider where you store all of your state. If you look at my local system while I was doing all those Terraform applies, it's using my local file system to be able to store all of the things it's created in the history, and it knows what is out there and what needs to be created and what needs to be modified. Terraform Cloud allows you to store that inside of their infrastructure. Some customers are concerned with security, as well as they want to be able to host this themselves. The open source provider works very, very well. You get nearly the exact same capabilities, but you'll end up using a backend provider. I like using the S3 provider that allows you to basically use S3 and Dynamo as the storage backend for state. But there's also many, many different backends. So depending on what cloud provider you use and how you want to do it, you'll be able to use those also with the free version. But it's important to store state remotely. I think anytime it's stored inside of a local system, Terraform will get really confused when you have like one developer that may have brought up his environment from a local file, and then another developer maybe checks out the same Git repo and then does a Terraform apply. Those are going to get very confused because it doesn't have the history of what's happened in that production environment. You'll get error message saying like database already exists, and warehouse already exists in my previous example because the state doesn't exist there on the new developer that checks out from GitHub. So when you start doing anything where you're sharing those GitHub repos with multiple teammates, as well as running it inside of a CI/CD system like GitHub Actions or something like that, strongly suggest removing all the state from local systems. And in most cases, even for developers, I would say using remote state is a best practice, because now it allows you to tear those down. If you imagine if I would have brought up that environment on my local laptop and then I lose my hard drive, it'd be really nice if someone else could go out and just destroy my environment, just running a Terraform destroy. And if I would have used remote state there, that would be possible. And you could also automate all those development teardowns through external systems if you're using remote state storage. In the previous case today, I didn't use any modules, but if you have things that you're doing a lot, so if you have repeatable patterns where you're like, hey, I always add this type of service credential like that user I was doing earlier, and I always add a database and a schema, and I'm always granting this user access to a database, that's an exact example of what would be great as a Terraform module. And modules can be reused and imported into any number of GitHub projects or other projects that you have inside your organization. So that can be something one team can organize and develop and make more robust, and they can harden that one version of that module. And then many teams can use it. And then when they actually use that module, they'll get the whole thing stood up in seconds, just importing it, which is really nice. Earlier I didn't show a plan coming out, but I do think it's important to at least review the plan that's getting generated on a Terraform apply. If not, also do a Terraform plan, look at the output, make sure you understand those, make sure you're reviewing those plans before you say yes. I've had more than a few incidents in production systems where things were dropped that were not expected to be dropped, and it was all sitting in the plan that we could have seen. There's quite a few cases where people are modifying YAML files. It's very easy to accidentally delete a block. It's very easy to make an unintentional change in there. And if you're not looking at those plans, it's a very easy way to introduce massive change on accident. That's where pre-production environments are very important, as well as reviewing those plans. Hopefully you're catching that by doing it in a pre-prod environment, and or at least reviewing the plan in production if you're in a production environment. As I mentioned earlier, also running these environment changes through continuous integration, I think is really important, especially when you get up to a point where you want to test before you get to production in something that looks like production, right? So at least having one environment that is like a staging or pre-prod environment that does run just like production, that does have a similar state, that does have a similar, it hopefully is using the exact same Terraform projects, and applying it before you end up applying it in production, so you can both audit as well as automate all of this. So this will save your teammates time. Like in this case earlier, if I just need to resize my warehouse, I could have done a pull request, changing the size of the warehouse, committed it. The CI/CD system could have automatically merged that, as well as deployed it into pre-prod and then propagated that all the way to production after that was successful. So it's very, very easy to automate these types of changes, where now it's just a GitHub change inside of a repository, and it just gets into production, with it no longer being like manual JIRA tickets to a DBA team that can go out and size these. Now it's just a pull request and an approval before it lands there. The last point I would like to say is also, like, Terraform can't solve all the shapes of problems that exist inside of database change management. It's a great tool to be able to change and manage infrastructure through code, but there's a line where it's very, very challenging to use Terraform. And a lot of this is around like data migration and data changes needed. And Terraform is great for being a declarative tool that says, hey, I want the destination to look like this. If you make a change to a table and you say, I want the destination to look like this, and you've done something like, remove many, many columns or something, or dramatically change a table structure, Terraform wound up just saying, oh, I don't like the look of that. That doesn't look like what you want it to look like. So let me just drop it and I'll recreate it. Terraform will do its diligence. It'll drop the table. It'll recreate it the way you want it to look. But you just lost all the data that was sitting in the table, right? So think through what pieces belong inside of Terraform as well as what should be inside of other tooling. When you're looking at imperative tools that pair well with Terraform, I think we see a lot of customers using technologies like Flyway and Sketch. We have a tool we built called Schema Change. But there's a whole ecosystem of tools that are imperative tools that help with these data migration needs. DBT is also very popular here to be able to host and change the models in place. It's one reason why I didn't demo today, creating a table as well as changing a table in production. While it's possible, I think it's probably the wrong tool for the job, and it will be probably for into perpetuity. It's not that Terraform isn't a good job at doing that. It's that Terraform's not designed for doing that. It's designed for making the destination look like the way the Terraform. So hopefully that was a good review of Terraform. Hopefully you guys got through the hands-on lab. We do have the questions going through right now. So if you do have any last-minute questions, feel free to send those in. If you're having any issues or have any more questions of our team, please reach out in chat and or to your account team at Snowflake, and we'll help you out. So appreciate your time today. Thank you.